We are starting our study now on reactions and the types of ways that elements bond together. And the first one we're going to look at is ionic bonding. And then after a couple of weeks of studying this, we will look at covalent bonding. So we are going to take a moment to look at the specific properties of ionic bonds so that when we get to covalent bonds, we can differentiate between the two. Some key properties of ionic bonds is first that they're defined as being types of bonds that occur between metals and nonmetals. So you have kind of this idea of opposites attract. You've got a metal and a nonmetal that work together, and whenever you're writing a chemical formula for an ionic compound, you will write the metal first. Just a little note there. Metal first. When we write the name, when we write the formula, metal is always first. And you'll see here at the top our title says give and take, and so the octet rule for ionic compounds is followed by transferring electrons. Metals will give, nonmetals will take, and that will cause metals to be a positive charge and nonmetals to be a negative charge, and together those opposites attract one another. Other key properties of ionic compounds is that they are solid at room temperature, and we call them salts. So they are solid salts with a high melting and boiling point. They are conductive in water, which means that they will conduct electricity and heat when they are dissolved in water. So they are conductive. And they are also soluble. They will dissolve in water. There's our key properties. The main one being that it's made of a metal and a nonmetal. So if you're ever looking at a compound trying to decide if it's ionic or not, just look at your periodic table and go back to the distinction of metal and nonmetal. All of the metals are on the left, except for hydrogen, and the nonmetals are on the right. If you have one on each side, it's an ionic compound. Next, we have Lewis structures, which are going to help us represent the valence electrons of our ions. Remember, valence electrons are really helpful because they are going to be representing how the electrons are going to change to follow the octet rule. If we have 7 valence electrons, we talked about how the halogens are very, very reactive because they want to get to 8 to become stable, so they will gain 1 electron. And then the alkali metals, they will give away 1 electron to become stable. We can show the valence electrons visually using a Lewis structure. So a Lewis structure is just a visual dot representation of our valence electrons. And the way that you write a Lewis structure is really straightforward. You start with the element symbol, and then you use dots, 2 on each side of the symbol, to represent the valence electrons around it. When you have 8 dots, that will fill the Lewis structure. That represents a stable full octet. But also remember that 0 dots, those 0 valence electrons, when we have a metal giving away, will also represent a stable atom, because that will mean that the previous shell is the outermost full shell, making it stable. Another note to remember is that our valence electrons match the A group on the periodic table. And those are, if we look at this periodic table in the ion box, it's 1 valence electron, 2, then we skip the D block, 3, 4, 5, 6, 7, 8. That's your numbering of the valence electrons, and that matches the A grouping. So let's do a couple examples down here. It says, we're just going to do part of this. Shade in the atom's electrons to complete their Bohr models and determine how many valence electrons each has, and then draw the Lewis structure with arrows to show the movement of electrons. Describe how each atom follows the octet rule to become stable. Identify the resulting ions and chemical formula of the final compound given the atoms. We have aluminum and nitrogen. Aluminum is a metal. Nitrogen is a nonmetal. So these two, when they bond together, will form an ionic compound. If you look at your periodic table, you will see that aluminum has 3 valence electrons, but it has a total of 13. So we're going to shade in our 13. And we're actually going to see these 3 valence electrons pop out for us. We know that there are 3 because we have 3 in this outer shell. Then we will fill in for nitrogen. If you look at the periodic table, it has 8 electrons, which will result, 7 electrons because it is number 7, and it will result in 5 valence electrons, those outermost. There's 5. Okay, so writing the Lewis structure, like I said, you'll write the element symbol and then you'll put dots around it. It can hold 2 on each side, but first put 1 on each side. So there's aluminum, and then nitrogen, 4, 5. Okay, so there's our Lewis structure. It's showing the valence electrons for each of these atoms that are going to bond together. When our atoms bond in an ionic compound, they are going to transfer, give, and take electrons, causing them to become charged. And remember, a charged atom is called an ion. And we have 2 different types of ion. We have a cation and an anion. And the cation is positive, and an anion is negative. And a little way to remember this that is kind of silly, but it helps me remember, is that a cation has, it's like a cat, has positive, it has little paws, positive, and anion kind of sounds like onion, so onions smell bad, it's negative. I don't know. If it helps you remember, great. So cations are positive and anions are negative. And that is because cations are going to give away electrons. That's metals. Metals will be cations. And anions are going to gain electrons. Those are the nonmetals. Remember that the charge comes from atoms gaining and losing electrons. Cations lose them or give them away. Anions take them and they become more negative. So if you look at the periodic table that's provided here, let's just go through and summarize the charges that we'll see based on their valence electrons. So we've already talked about the alkali metals are in group 1A, and they're going to have 1 valence electron and give that 1 away, which will result in a positive 1 charge. So right, positive 1 over that group. Then our next group, alkaline earth, has 2 valence electrons, so they're going to result in a positive 2 charge. Group over, if we skip the D block, has 3 valence electrons. That would be a positive 3 charge for that group. The fourth group here, they actually do not transfer electrons. They're right in the middle. They actually end up sharing more of the time, so we do not really include those with our ionic. Sometimes they'll do a +4 with these down here, but overall, they will share, which is a covalent bond, not ionic. Then we kind of hit that pivot point where we have 5 valence electrons. Now we're going to gain to get to 8. So we'll have to gain 3 for the nitrogen group. Then when we have 6 valence electrons, we'll gain 2. Halogens will gain 1. And then, of course, our noble gases do not gain any or lose any. So we've got +1, +2, +3, then nothing, -3, -2, -1. That is our charge pattern for the ions. Our last type of ion that we're going to talk about, and then we'll finish this example in a part 2 video, is a polyatomic ion. And a polyatomic ion is still a charged ion, but instead of just being one atom, it is a group of atoms that acts as a unit and carries a charge. You'll see, I think it's on page, it's in a couple of pages if you flip through. There's a list of common polyatomic ions that you can reference while you're working on these. There are lots. These 6 right here are the most common ones that we're going to be using, and I would suggest memorizing them: ammonium, hydroxide, nitrate, carbonate, sulfate, and phosphate. We'll be using them a lot, so you might just naturally memorize them as we use them. But you'll want to know the charge, and you'll also want to know all the little numbers and things like that when we are using these. That will be really helpful if you can memorize them. So we're going to stop here, and then we'll finish the example in a part 2 video.